Today we're going to talk about power functions. And power functions are any function of the form f of x equals ax to the n, where a is the coefficient, x is the variable, and n is the exponent. A power function is also a type of monomial function, and we can draw a sketch of each of the following. So a constant would be f of x equals a constant. So we could have f of x equals 2, 3, and it would look like this. The linear is f of x equals x, and that's a line. The quadratic is f of x equals x squared, and that's the parabola. The cubic the quartic looks like this. It's just a little bit fatter than the parabola. And the quintic is just a little bit fatter than the cubic. So if the function has an even power, it has y-axis symmetry. So it's symmetric around the y-axis. If the function has an odd power, then it has origin symmetry. So if I have an even power and a positive coefficient, so the coefficient in front of the power function is positive, then it's going to be like our parabola. And the end behavior, as x goes to infinity, f of x is approaching oh Lord. As x goes to infinity, my y's are approaching infinity. As x goes to negative infinity, my y's are still approaching infinity. So even power, positive coefficients, the end behavior is up and up. Even power, negative coefficient, then the end behavior is going to be down and down. So as x approaches infinity, my y's are approaching negative infinity. As x approaches negative infinity, my y's are approaching negative infinity. For an odd with a positive, it's going to be like the cubic. So the end behavior is going to be down on this side and up on this side. So x approaches infinity, my y's go to infinity. As x approaches negative infinity, my y's approach negative infinity. So odd power, negative coefficient, it's exactly the opposite of this one. So instead of down, I'm going to go up on this side, and I'll go down on this side. So as x approaches infinity, my y's approach negative infinity. As x approaches negative infinity, my y's approach positive infinity. So when we graph these, I have a positive and it's even. So I have a positive leading coefficient and it's even. So I know that my from the page before, I know that my end behavior is this. So the end behavior of this graph has to be up and up. So this is the vertical stretch of 3. So if I put 0 in, I still get 0. So my 1, 1, it's a vertical stretch of 3, so I would be at 3. So a negative 1 would still be at 3. So my domain is negative infinity to infinity. My range is negative infinity to infinity. My x-intercept is 0, 0, which makes my y-intercept 0, 0. My increasing interval would be 0 to infinity. My decreasing interval is negative infinity to 0. Symmetry around the y-axis, because it's even. There's no discontinuity. And my end behavior, as x goes to infinity, my y's go to infinity. As x goes to infinity, my y's go to infinity. As x goes to negative infinity, my y's still go to positive infinity. Okay, so my points, did I just make them up? I didn't. If I put 0 in, I get 0 for my y. If I put 1 in, I get 3 for my y. If I put negative 1 in, I still get 3 for my y. So I'm just plugging points in this to get points on the graph. So if I look at this one, what's the leading coefficient? I have a negative leading coefficient, and this is odd, which means that my end behavior is here and here. So if I put 0 in I get 0. If I put a negative 1, I end up with positive 2. If I put a positive 1 in here, I end up with negative 2. So here's my graph. So my domain is negative infinity to infinity. My range is negative infinity to infinity. My x-intercept is 0, 0, which makes my y-intercept 0, 0. I have no increasing interval. It's all decreasing. It's symmetric around the origin because it's odd. There's no discontinuities. And as x approaches infinity, my y's approach negative infinity. They go down. As x approaches negative infinity, my y's approach infinity. So here, I have a negative leading coefficient, and it's even, which means my end behavior is going to be this. So if I put 0 in, I get 0, 0. Well, that means my x-intercept and my y-intercept are both 0, 0. If I put 1 in here, I get a negative 1/2. And if I put a negative 1 in, I end up with a negative 1/2. If I put 2 in here, 2 to the 4th is 2 times 2 times 2 times 2. So you get 4 times 4, which is 16. And if you divide that by 2, then I get negative 8, which is here. And I end up with the same on the other side. So my domain is still negative infinity to infinity, But what's my range this time? Negative infinity to 0. My increasing interval is negative infinity to 0. And my decreasing is 0 to infinity. It's symmetric around the y-axis because it's even. There's no discontinuities. As x approaches infinity, my y's approach negative infinity. As x approaches negative infinity, my y's approach negative infinity. And y'all, this range, this was not infinity to infinity. This is the top example. And if you didn't get the bottom, here's the answer. So go ahead and start your homework now.